So today we're going to get into permutations and combinations, some counting principles which are pretty cool. You think about things like how many different passwords would there be? How many different locker combinations would there be for different situations? So those are some of the things we'll address in this lesson. So first, again, I'd encourage you to write these things down. They're going to help you as you go through the lesson and get into the practice quiz. Permutations involve a set of objects in an ordered arrangement. So order's the key. So for example, how many ways could 3 objects be lined up on a shelf? And imagine you got 3 trophies or something. It doesn't really matter. Okay, I've basically got 3 slots. Well, if I have 3 objects, how many objects could I hang here? Well, I could hang or set 3 different objects. Well, how many could go in the second slot? Well, now I could put 2 because I've already used 1 here, and then of course the last slot I've only got 1. And then here's the principle. I multiply those together, 3 times 2 times 1, and I get 6. Alright? Now I've rewritten that here. So we could rewrite that as 3 times 2 times 1, we get 6 different possibilities, 6 different ways. You could try this with a small set like 3 objects and convince yourself of this pretty easily. We could also write this using something we call factorial notation. Maybe you've seen this before. Let me just rewrite that. Can you see that? 3 exclamation point. Well, that means 3 times 2 times 1. It's just kind of a shorthand way. And again, we don't say exclamation in math. We say factorial. So let me show you something. What if we want to find 10 factorial? So 3 times 2 times 1 is pretty easy to multiply. 10 times 9 times 8 times 7, da da da. That's going to take a little longer, right? So we've got a button on our calculator. Again, you know Desmos is powerful for graphing. They also have a really cool scientific calculator you can use. So if you click function, this exclamation point, there's our factorial. So I'm just going to type it in. 10, and then push that exclamation. Boom, there's your answer right there. Now notice, this is a really big number, okay? You could convince yourself with smaller ones if you wanted to try it, but that's how we can do factorials using Desmos. Okay, let's keep going with permutations. So the number of permutations of n objects taken r at a time. We have this relationship, okay? Again, I'd encourage you to write this down. You don't need to memorize it or anything though. So in the previous slide we talked about, what if I had 5 objects I want to arrange? Well, it's just 5 factorial, no problem. But what if I had 5 objects and I only want to put 3 of them up on the wall at a time? Maybe if I got room for 3 pictures, I'm going to rotate 3 pictures. Well, that's where this comes in. So 5 objects taken 3 at a time. We've got this formula, okay? So if we plug stuff into that, we would have 5 factorial over n, now that's 5, right? Minus r, so that would be, what's r? What did we say? 3 factorial. Or in other words, that's 5 factorial over 2 factorial. Okay? So, different ways we could plug that in. Let's just do that quick in our calculator. So if I did 5, oops, let me click over here. Well, let's get rid of that. So 5 factorial divided by 2 factorial. Hey, that gives us 60 possibilities, okay? And so, let me get my pen back. So this equals 60 different ways you could arrange 3 objects out of 5. Basically, that's 5 times 4 times 3, if you think about it, okay? Well, what if that gets bigger? Okay, maybe we had 8, 2. So we've got 8 objects, but we're only going to use 2 of them. Now, I want you to think about that. Well, the first one you have 8, the next one you have 7, so it's just 56. But you could use this formula, or here's a little shortcut, alright? So you don't even need to use this formula, NPR. So 8P2 means you've got 8 objects, but you're only going to arrange 2 of them. So let me show you that button. So if you push NPR, sorry, let me clear this on my calculator. So if you push NPR, and then just do 8, 2. Hey, it comes up and says 56. Again, that's 8 times 7. What if I did the 5, 3 like we just did? Let me go back here. So 5, 3, just to do one we already did. Hey, it's 60. So that's how you put NPR in. Just push it, again, right here on your Desmos Scientific Calculator. Pretty cool. You may have a calculator do NPR as well. I'm just showing you on Desmos that's available to everyone. Okay, we talked permutations. That's where order's concerned. What about when we're not concerned with order? Now we're dealing with combinations, okay? Combinations are only concerned with selection, so groupings. Number of combinations, we have this formula, NCR. Okay, so NPR, permutations, NCR for combinations. Notice I've got an NCR button on my calculator as well. We can read this: combination of n things chosen r at a time. Okay, let's go look at a few examples. We see how we can do this. So here's some word problems. 10 students are asked to visit a college admissions counselor. The counselor can meet with one student at a time. How many ways can 4 time slots be assigned? So here's one way to picture it. Imagine if I listed out 4, well, how many students could come here? Oh, 10. Then there'd be 9 left, 8, and 7. So another way to do that, right, is a shortcut. You could just multiply those out. Or, let me just do this. We could do NPR, and we're doing 10, 4, right? 10 objects, students in this case, but we're only using 4 of them. Hey, we get 5,040. All right? How about this next one? A reading list for a course in world literature has 10 books in it. How many ways can you choose 3 books to read? Now, does it say anything about specific order? No. So this is a combination problem. So I'm going to do 10, choose 3. So push your NCR button, and we're going to do 10, 3. Hey, 120. Now NCR always going to be less than NPR, by the way, because combinations where you don't have specific order, the numbers are going to be much smaller. Okay, how about this next example? Disc jockey wants to select 4 songs from a CD that contains 10. How many ways can he choose 4 songs? Now, choose. Does it say anything about he's going to play? Does it say how many different orders could he play 10 songs in? How many ways could he choose 4 songs? Hey, that's like this one. So that's a 10C4. Now here's going to be a good illustration. This was 10P4, right? And it was 5040, 10CR. Let's see how that compares. So if I do 10, 4, notice 210, much less, because order doesn't matter. So there's 210 combinations of 4 songs out of 10. Kind of interesting. Okay, one more here. Coach needs to determine the batting order. How many ways can he arrange 9 players? Notice arrange. So if you listed out 1, 2, 3, 9 slots, well, you could put 9 guys in the first slot, 8, 7, 6, and down. Or in other words, 9 factorial, right? So for this one, we don't need NPR. You could do 9. You could do NPR and do 9, 9, by the way, 9, and you're using all 9. Or just shortcut it. Do 9 factorial. Whoops, so only need one of those. 362,880 different ways you could make a lineup out of that. Okay, so again, I hope this will kind of help get you into the lesson. And I wanted to show you the scientific calculator on Desmos for sure, so you know where some of these tools are.